Good morning. My name is Harold Nowak. I'm presenting a method for the rapid determination of the stopping time t in Collatz. The method is very fast and you can find t for extremely large numbers very quickly. First we define Collatz. S of n equals 3n plus 1 all divided by 2 for odd n. So dividing by 2 is now part of a single step for odd n. And d of n equals n divided by 2 for even n. Now we have the parity equation. In other places I've explained how I obtained this particular formula capital N equals 2 to the power of t minus x all divided by 3 to the power of k, where n is the starting value in Collatz and t is a stopping time in Collatz. That's the number of steps required to reach 1. Remember, I'm using the 3n plus 1 divided by 2 as a single step. X is the path number in Collatz used to reach 1. I'll explain how you obtain that later. You can also build x by using block catenations from 0 and using the operator 3 times capital N plus 2 to the power of n minus 1, where lowercase n is the block number. The fourth parameter is k, which is the number of s steps used to get to 1 in Collatz. It can also be built by block catenations of 0 using the operator plus 1. So you can see we have 4 interconnected values, n, t, x, and k. Now you can get the general formula for x for a given k. Each k has many x values. Now a number x belongs to the level k if it can be written as x equals 3 to the power of k minus 1 times 2 to the power of a, then plus 3 to the power of k minus 2, times 2 to the power of b, then plus 3 to the power of k minus 3, times 2 to the power of c plus, all the way to 3 to the power of 0 times 2 to the power of f. Now a is less than b is less than c is less than, all the way down to less than f. And a is greater than or equal to 0. So you have falling powers of 3. And rising powers of 2. That's the general formula for x for a given k. We have parity equation and we can rearrange that to show that x equals 2 to the power of t minus n times 3 to the power of k. Now you fix your value of n. You can guess a value of k. Let's start off with k equals 1. The value of x is positive. So on the right hand side of the equation we have the inequality 2 to the power of t has to be greater than capital N times 3 to the power of k. Or in terms of t has to be greater than log base 2 of n plus k times log base 2 of 3. You have n and k, so you know t has to be the first integer above this expression on the right hand side of the equation. Say it's 6.86 or something like that. Well, t min equals 7. If k is the correct value for n, then almost invariably t min is the correct value of t. Rarely it can be t min plus 1. Now place n, t min, and k into the equation and find x. The next thing you do is you determine whether x is valid. If x is valid, then t is a correct value for that n. But if x is invalid, test another value of k. You can increase k by 1 and quickly you will find the correct k. Now we ask the question, how do we know whether the x is valid? You examine the equation for x. Divide this expression by 2 to the power of a, that is, take 2 to the power of a outside the brackets, and what you are left with inside the brackets is 3 to the power of k minus 1, plus 3 to the power of k minus 2, times 2 to the power of b minus a plus, term to 3 to the power of 0, times 2 to the power of f minus a. Only 3 to the power of k minus 1 is odd, so the whole expression inside the brackets is odd. Everything else is even because they're all powers of 2. So keep dividing x by 2 until it is odd, and the number of times that we divide by 2 is the value of a. Take the first term over to the left side of the equation to get x1 and solve for b in the same way. Divide by 2 until odd, and the number of times you divide by 2 is the value of b. Keep going in this way to find c all the way to finding f. At the end, if you reach 1, then x is valid, so that's the way you're testing to see whether x is a valid value. It's a very quick, you do it on a computer, it will only take a fraction of a second to determine whether x is valid or not, even if you've got a lot of terms. And if you have the values of a and b and c, etc. Just add 1 to a, b and c, etc., and these are the position of the s steps in the path from n to 1. You know the value of t, so fill in the other steps with d. Your first guess for k can be 1, and if not correct, then test higher and higher values of k. For n up to 40,000, k does not climb above 120. Therefore, you can go through a maximum of 120 guesses for k before getting the correct t for every n up to 40,000. Starting off at k equals 1, You may think that's a bit silly, so you can start at higher k values for larger n. For very large n, it may be a better idea to start k higher using 2 to the power of t min. For a particular k minus n times 3, the power of k has to be greater than 3 to the power of k minus 1. I'll call that an altitude gauge. And once it flips from false to true, you're in the zone where k is worth serious attention. So you can use this method to trim the number of k values you need to test. You can see that the method is extremely quick, and you can check n values up to say n equals 10 to the power of 2000 and quite rapidly find the value of t. Now some of you may be a little bit confused by the method, so I'll take a really low value of n and just go through the process. So for example, let n equal 23. First we test k equals 1. We have the formula to work out the minimum value of t. 'Tis greater than 6.11. So t min equals 7. You plug in n equals 23, k equals 1 and t equals 7, and so x equals 59. Dividing x by 0 times before it is odd. Now 59 does not equal 1, so x is invalid. Test k equals 2. Tmin equals 8, so x equals 49. This gives a equals 0, b equals 1, and x2 is not 1, so x is invalid. Now you test k equals 3. Tmin equals 10. X equals 403, a equals 0, b equals 1, c equals 2, and x3 is not 1, so x is invalid. Move on to k equals 4. Tmin equals 11, x equals 1, 85, and a equals 0, b equals 1, c equals 2, and d equals 7, and x4 equals 1, so x is valid. So now for n equals 23, t equals 11, and you've got a plus 1 equals 1, b plus 1 is equal to 2, c plus 1 is equal to 3, d plus 1 is equal to 8. So you've got the path S, 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 D, 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 S, D, D, D. That is a simple method for finding the stopping time t for any value of n. And you get the path too. I hope you enjoyed that, and thank you very much.